高兴请到亚利桑那州立大学的经济系的博士候选人张坤，然后张坤的主要的研究领域是信息经济学以及信息经济学在这个产业组织理论、合约理论和金融经济学中的应用啊。那他对这个信息设计，包括这个 verifiable disclosure 啊等这些这个分支是有一些很有趣的研究啊。那我们这个今天他给我们带来的分享是 Uncharted Waters Selling a New Product Robustly。那么我们的 seminar 是持续1个半小时。那在这个过程之中，如果大家有任何的问题，可以通过这个聊天框来提问，或者是可以直接接触你自己的静音，然后向这个主讲人提问，好吧？那我们现在把时间交给张坤。
好，谢谢杨老师。然后我今天就是之前问了杨老师，然后就是说，中文、英文讲都可以嘛？因为我这2天尝试了一下，然后中文讲的话呢，效果不是很好，因为有一些就是英文叫 jargon 或者就是黑话，可能中文讲起来这个越讲越糊涂，所以可能我就试一下用英文讲，然后如果说大家有什么问题呢？欢迎大家就是可以直接用中文问，然后我也可以尝试着尽量用中文回答。如果有哪个地方讲的不清楚，然后就是可能如果哪位老师或者同学愿意就是说希望我能用中文再解释一下的话，那我也很乐意去用中文解释。好，那就谢谢，那我就现在开始。然后今天，OK。So today I'm going to present this project or paper, Uncharted Water, Setting a New Product Robustly. So rapid technological development has brought more and more new products to us. Examples, just to think of, smartphones, electric vehicles, and wireless headphones, just to name a few. But you can find way more. Okay, so in selling a new product, often the seller not only sets a price, like in standard, economic models, but also provides some information about the product. In the last, I don't know, a year, when I started working on this project, I observed some interesting phenomena emerge in the markets of new products. So, for example, these McKinsey principles in this article claim that companies habitually charge less, than they could for new offerings. It's a terrible habit. I wonder if we don't just think about everything is about pricing, but also take information provision into account, can charge less than they could be actually explained by, like economic theory than just claiming it's a terrible habit. Okay, so by the way, if you're not sure what do I mean by providing information or information provision, you can just think about like the sellers offering trial periods or providing product samples or just showing product descriptions or like letting the consumers watch some informative commercials, let's say. Okay. Another observation I had is that there's a lot of variations in information disclosure policies on new products. For example, if you look at this e-reader margin node, which basically the innovative point is that it integrates the mind mapping or flashcards to a traditional e-reader. It only offers a 14 days of free trial. In contrast, this first ever e-ink tablet, Remarkable, allows full refund within 100 days. Okay, so why do at least like how can we explain these kind of large variations? Okay. So in this model, or let's say to understand these phenomena emerge in the markets of new products, I study a model in which a seller has a product with unknown match value faces a buyer with unit demand of the product. Okay, so by unknown match value, I really mean that it is also not known to the seller because it's based on the buyer's taste. Okay, like this is going to be important. So the seller sets a price and chooses how much information to provide about the product. And after seeing the price and information, I assume that the buyer can search for an outside option at a cost. Okay, so because of the novelty of the product, it's important that I assume the only information the buyer can obtain is about this product is from the seller. However, it is still likely that the buyer could check the pricing and features of some other products she deems as substitutes. Okay, so basically you can think about this outside option as a buyer's best alternative. Okay, like another important assumption I make in this model is that the buyer knows the outside option distribution. However, the seller only has limited information about the buyer's optimal distribution. Outside option distribution. Okay, the assumption seems reasonable to me. At least it's because, seller, for example, could know very little about how the buyer acquires or processes information about the alternative, or what substitute products does the buyer has in mind. Okay, so and seeking robustness to this kind of uncertainty the seller faces, she would evaluate any selling strategy by its guaranteed profit. By guaranteed profit, it means that the lowest possible profit that is consistent with her information. So of course, it's probably worth to mention that this objective is not my invention, but rather intensively used in the literature. For example, you can think about many papers by Gabriel Carroll or the already very well developed robust pricing literature. Okay. If you want me to explain why this objective is reasonable, intuitively, you can think of when you launch a new product, you want this product that not to behave too bad, or like the revenue is not too bad, no matter what happens, or no matter what unforeseeable happens. Okay, so here this objective essentially provides this idea of doing reasonably well, no matter what happens, because it is maximized under this guaranteed profit. Okay. All right, so the main trade-off studied in this paper is between demand and extraction. So the idea is that because the seller can design information, she can essentially manipulate the buyer's beliefs and boost demand by deterring the buyer from search. However, to deter the buyer from search, the seller must provide the buyer with sufficiently high or payoff, but that might actually drive the price low, and which is therefore bad for surplus extraction because the price is low. Okay, there are three main research questions I would like to understand in this paper. First is that, as standard in any theory paper, what is the optimal selling strategy if the seller can design both price and the information provision strategy? And also, is the buyer better off when learning about her alternatives becomes easier, namely the search cost becomes smaller? Okay, and finally, how do our results shed light on selling different kinds of new product? In particular, how would it explain the two somehow puzzles I mentioned at the beginning? All right. So to quickly preview the results, the form of the optimal selling strategy would depend on the search cost of the buyer. So full information is optimal only when the search cost is sufficiently high. Okay. Otherwise, if for let's say low or intermediate search costs, different kinds of partial information provision could be optimal. And when the outside option distribution is known, instead of being the seller is taking a robust or max mean approach here, full information is instead always optimal. Okay, So that wouldn't explain at least the large variation like we observe in the markets of new products. So there are also some interesting comparative statistics. First is that the price is non-monotone in the search cost. This is interesting because conventional wisdom in search literature basically says that, okay, as the search cost increases, the seller wants to charge a higher price because the buyer is less likely to search. However, here, for a higher search cost, the price might be lower for the corresponding price than the corresponding price for a lower search cost. That's what I mean by non-monotone. Furthermore, information provision actually becomes more precise as the search cost increases, okay, which is also a little bit counterintuitive. This is much more, let's say, subtle, which depends on both of the main assumptions of the introduction of the search friction and also the robust seeking objective of the seller. So I will just not explain it now, but leave it for later. Okay.
张控，不好意思打断一下，
好，
不好意思，我就用中文提问吧。
没问题，没问题，大家都
我
随
想问一下，
便问。
你的这个价格是 search cost 的那个非单调这个性质，是不是在 search cost 比较低的时候是成立的呀？
哦，是这样的，它实际上它基本上都是增的，但是它在有一个点，它会有一个这个 jump down，就是它会有一个怎么说呢？有一个下坠。
我的理解是根据你上面这个结论，就是如果 search cost 很高的话，你这个 full
对，
information 就是 optimal，对吧？那如
嗯哼，
果 full information optimal 的话，那应该跟这个 search literature 里面的结论是一致的呀，就是你应该还是满足单调的。所以，
对对，这个是对的，这个是对的。实际上就像我刚才讲的，它只有在一个点是会这个有一个 jump
嗯
down，有一个下坠，在其他的点
嗯
都是这个应该说是 strictly increasing。对
哦，好的好的，谢
对，
谢，请
好，
继续。
谢谢你的问题。然后 OK， so let's yeah, so basically of course, I've talked about a lot about my model, but what are the implications for, the selling new products? First, it provides an explanation for the large variations in the information provision policies among new product. Let's just remember, we talked about the e-reader and the e-ink tablet, right? It's like 14 days, 100 days. And also, there might be some technological advancement that lowers the search cost of the buyer. But notice that our results predict that it might actually increase the price and result in less precise information provision, which actually make the buyer worse off. So a little bit, if we just push a little bit farther, like, the policymakers might want to be careful when they implement some, I don't know, like policies or whatever reforms that reduce the search cost, because that might not be actually better for the buyer. Okay. And the last point is a little bit more subtle, and again, I'll explain it in more detail later, is that a lower price, instead of being a bad habit, as observed at the beginning, it might be used paired with information provision to ensure more effective search deterrence. That means to make the buyer more likely to buy without search. Okay. So I guess the time is still fairly okay. So let me just talk a little bit more about literatures before I talk about my own contribution. Basically the most closely related literature is about selling a new product with information disclosure. There's basically these two papers study problem like this. But here, my contribution is that I introduce this both search friction and like seller's robustness concern into this kind of problems. Okay, and on a higher level, if we want to talk, above this main application of selling new products, this paper just lie at the intersection of two strands of literature. First is the robust pricing literature I've already mentioned. In this literature, like seller has less uncertainty about the buyer's distribution of valuations of the product instead of the option distribution like in this paper. Furthermore, the seller does not provide any information unlike in this paper, okay? And another literature studies pricing with information disclosure and consumer search. Probably most like famous one is this Anderson and Renault. But here, like, okay, so in all these papers, they study, or how do I say this? Okay, so in all these papers, the buyers would search for a more precise estimation of her valuation of the seller's product. But here, the buyer search for an alternative product or an outside option, okay? Another, let's say, contribution of this paper is that it introduces a fairly novel, not completely, but fairly novel, way or channel of search deterrence, that is, use information disclosure or information design to deter search. So this is like different from papers like Armstrong and Joe using price-based tools. That means if you buy now, you can pay a lower price, but if you come back from search, like you have to, like the price has to increase, okay? And another literature studies search obfuscation, in that the seller can manipulate the search cost. She might have an incentive to increase the search cost to deter search. However, here, the search cost is exogenous, the seller has no control over, okay? So finally, this paper is related to the information design literature under non-probabilistic uncertainty or robust information design, if you want. So what's different about like between these two papers, at least like this paper and this literature, is that of course I consider pricing. So adding the price channel shifts the designer's objective from increasing the odds of certain actions being played to extracting more surplus. That would actually generate some novel insights on the design of the optimal information disclosure policy. Okay. All right. Okay, so I think I actually already talked about, oh, sorry, it's another way around. Very good. I already talked about my contributions here. So let me pause here to ask if there are some questions. Otherwise, I jump into the model.
Hi, Quinn. I'm wondering if the second point here is actually the same intuition from Choda and Kim 2018 econometric paper, because they also have the same result, that the lower search cost is going to increase the price.
It's a great question. Thank you. So the intuition is actually very different, I think. I mean, at least I would put this way. So in their work, they are like, competing sellers, and the intuition is that increasing the search cost would make attracting, because, okay, again, in their paper, all the sellers can, post the price to attract like buyer to visit first, right? So essentially, like the search cost increases means that conditional on buyer visiting a seller, it's less likely for her to leave because the search cost is high. So that means it's important to like use price as a like attraction tool that drives down the price. But here, intuition, or let's say higher search cost means that, like, you want to make the price competition more fierce because they want to, the search, or let's say attraction motive becomes more important. But here, it's very different in the sense that it's really because of the last slide. Sorry, I can't find it. Okay, really because of the main trade-off of demand versus extraction, in the sense that when the seller wants to deter search more effectively, she wants to lower the price, as the third bullet point mentioned. Does that answer your question?
Yes, I see. Yeah, thanks. Interesting.
Yeah. Thank you. Great. So let me just jump into the model, but of course, feel free to interrupt me. Oh yeah, before let me just briefly talk about the outline of today's talk. First, I talk about the model, then I present the main results. And next, I explain what are the implications on the sale of new products of our main results. And next, I talk about the comparative statics results in more detail. Finally, I guess I would have a little bit of time, then I would talk about the variations and extensions of the model. Okay. Cool. So let's jump into the model. There is a risk-neutral buyer whose match value with the product is binary 0, 1. Okay, so x equals to 0 means that she doesn't like the product or it doesn't match, and x equals to 1 means that she likes the product or the price matches pretty well. Okay, so the prior probability that the match value is high is given by mu. Okay, this mu is known to the seller, but let me just emphasize again that the seller doesn't know this match value because it is assumed to be completely horizontal and only depends on the buyer's taste. Okay, so you might want to think this way that I abstract away the quality or vertical dimension, and the only relevant dimension in this model is horizontal. So what I just said might piss off Renkun, but that's fine because at least we are studying different problems. Okay, so again, seller knows this prior. So this is common knowledge, mu, and her production cost is normalized to 0. This is 不好意思，这个 control 我不太会用。Okay, so seller sets a price P and provides some information. How do I model providing information is deferred to the next slide. Okay, the buyer can draw an outside option V from a distribution G supported on the unit interval if she incur a search cost S. Okay, the buyer knows this distribution, but the seller doesn't. She only knows that the mean of this distribution is given by this C. And so now C is the mean of the outside option distribution. And she also knows that the distribution is supported on the unit interval. Okay, this assumption is just to make sure that the search opportunity is non-trivial. Otherwise, the buyer would never search. Finally, I'm going to assume free recall in the sense that the buyer can return to buy the seller's product costlessly. And importantly, I assume that the price does not change when the buyer comes back from search. This reflects the assumption that the buyer's identity is anonymous, which is probably like a pretty good assumption, especially when today's it's probably hard for you to change prices momentarily. Okay. All right, so let me talk about information provision. So as standard in the literature, sellers provide information by using an experiment. And the experiment is paired S and chi. Whatever. So the S is a set of signal realizations, and this chi maps the state to a distribution over signal realizations. Okay, so essentially, observing a signal realization, the buyer would update her beliefs from the prior and form a posterior W. So W is the posterior probability that the match value is high. Okay. And of course, since a signal realization maps to a certain posterior, then it is without loss of generality to assume that the seller directly choose a distribution over posteriors, I denoted by H. This is common H and Ganskow, which is standard in the literature. Okay. The only restriction we have to impose on the set of distribution over posteriors that is available to the seller is that the expected posterior must equal to the prior. This is just a consequence of the law of iterated expectations. So henceforth, I will focus on this distribution over posterior H, and sometimes I will refer it as the information disclosure policy or just disclosure policy for simplicity. Okay. So now the seller strategy can be summarized by the pair of price and this distribution over posteriors H. Okay. And after updating, the buyer's net payoff from buying, is just the difference between her posterior and the price. Y is her posterior expected valuation exactly equals to posterior because previously assumed that the match value is binary 0 or 1. So the posterior probability that the match value is high or is 1 is just W, and that's exactly her posterior expected valuation. Okay, so like as I already mentioned, to deal with what she doesn't know, what the seller doesn't know, she takes a robust, or some people prefer to call it the max-mean approach. As this name suggests, the seller maximizes the minimal profit across all possible offset option distributions with this known mean and supported on the unit interval. Okay, so if we want to take a metaphorical approach, or metaphorically speaking, the seller is choosing this pair, price and disclosure policy, to maximize her payoff as if there is an adversarial nature who observes this choice and then chooses a distribution, chooses an offset option distribution with mean C supported on the unit interval to minimize the seller's payoff. So we can think about this game as, instead of having 2 players, seller and buyer, now having 3 players, okay? Seller, nature, and buyer. This metaphorical approach is very useful in solving the robustly optimal selling strategy of the seller. So the timeline of this paper or model is as follows. First, the seller chooses a selling strategy, price, and information disclosure policy or distribution over posteriors. And then nature chooses offset option distribution G. Okay, so the buyer, on one hand, she draw a posterior W from this H, the information about the product itself, and she also observes this offset option distribution. Okay, so at this point, she would buy immediately if the net value of net payoff, that she gets from the seller's product, the difference between the posterior and the price is large enough. Otherwise, she would pay the search cost, draw an offset option from this distribution, and if she searches, she would only go back to seller when the net payoff from seller's product is strictly greater than her offset option. Okay. So the seller's so to state the seller's objective function, it's important to first understand how the buyer behaves in this game. Of course, already we're hinted quite a bit over here, but what do we mean by large enough? This is defined by this A, okay? So A is a variable that's implicitly defined by this equation. Essentially, it represents the net value buyer needs to forgo search. So why is that? Because the left-hand side is the net payoff. You can think of the left-hand side as the net payoff from seller's product, and the right-hand side is the expected surplus from search. Okay, so basically, because if the net payoff from the seller's product is A, the buyer is going to be indifferent from searching or not, and hence, if the net payoff is greater or equal to A, she would purchase the seller's product without search. Okay, Instead, if it's not the case, the buyer would pay search cost, investigate the outside option, and return to buy from seller if like the net payoff from the seller's product is strictly greater than her outside option. So notice that now the buyer eventually buys from the seller when one of these two things hold. Okay, so this is equivalent to that the difference between net payoff. The net payoff is greater or equal to the minimum of A and V. Okay, or this is the event. Because H is the distribution over posteriors, is the CDF for this posterior W, the eventual probability of purchase is given by this. Okay. Therefore, for fixed price P and the outside option distribution G, the expected demand is just this term. Okay, take expectation over this V because this is unknown. And then if you multiply that by the price, this is the seller's revenue. It's actually also the seller's profit because the production cost is normalized to 0. Okay. All right, so to solve this problem, I first transformed this clearly dynamic problem to a static one. Okay, so this is first observed by the Armstrong paper and also the Choi, I think, Dai and Kim paper. We just talked about. So we are going to define this new variable z as the minimum of A and V, which is just this thing appears here. Okay. And we're going to let this G hat denote its CDF. Okay. So by definition of this, A, which is just the surplus needed for the buyer to forgo search, we can find that the mean of this variable Z is given by C minus S, that is the difference between the mean of the outside distribution and the search cost. Furthermore, the range of this variable, or basically the support of this variable, can be at most from 0 to 1 minus S over C. Okay. Therefore, the objective function by defining the C, if you replace this minimum of A and V by Z, is now just given by this, okay, this term. So essentially, nature is choosing this G hat distribution over this new variable Z to minimize the seller's payoff, and the seller choosing her selling strategy, price, and information disclosure policy to maximize this. Okay. So to solve for this problem, I use a two-step approach. Essentially, for every fixed price P, okay, I'm going to solve for the optimal distribution over posteriors by finding the equilibrium, or let's say the saddle point, of a zero-sum game played by the seller who chooses a disclosure policy to maximize her revenue, and the nature who chooses an outside option distribution to minimize this revenue. Okay. And the second step is that after I find the optimal distribution, of course, it's dependent on this fixed P, I would optimize over P, and the price that is just can be obtained by using standard optimization techniques. Okay. All right, so if no questions, I start talking about the main results.
I have a question regarding notation. Yeah, sorry.
Yep.
I have a question regarding notations. If I understand it correctly, the nature actually goes next to the seller, right? So why don't you put a minimum sign outside the max? So it's the max takes place first, and the minimum take place second.
So you can think about the Stackover game, right? So in the Stackover game, the leader moves first, and the follower moves second.
Right.
Right. But it's exactly the same as here, right? Like the maximum is outside and minimum is inside.
Okay.
Because
I see.
essentially, yeah, exactly. Yeah, great.
Okay. Thanks.
Yeah, no problem. Cool. So thanks for the question. And then let's talk about the main results. So as I previously mentioned, the choice of this information disclosure policy, or in mathematical term, distribution over posteriors, is, has only one restriction, is that the posterior distribution has the mean equals to the prior. Okay. However, here, there are only three kinds of distribution over posteriors that could potentially be optimal. So, and actually, they also have some interesting features. Let me talk about them one by one. The left panel, I call it uniform disclosure, has a distribution that is linear in the interior of its support. Okay. Of course, linearity in the distribution just corresponds to a uniform distribution. And there may or may not be a mass point at 0, but no mass point elsewhere. Okay. So notice that this distribution over posteriors corresponds to a partial disclosure. Why is that the case? Because if you get the posterior at this point, let's say whatever it is, you are still fairly unsure about what is your match value. Okay. However, this one, the middle panel, is full disclosure. Why it's a full disclosure? Because it only takes two potential values of posteriors, 0 or 1. Only these 2 points has mass. Okay. So if posterior 1 realizes, the buyer knows that the match value is surely high. If posterior 0 realizes, the buyer knows that the match value is surely low. So basically, this disclosure policy fully informs the buyer her match value. That's why I call it full disclosure, because it's fully informative. Okay. So finally, the right panel, as the name suggests, you can think about somehow it's a combination between the previous two disclosure policies. Essentially, it has a top mass point at 1, and otherwise it is uniform on the interior of its support. Notice that it has no mass point except potentially at 1. So to summarize, the distributions are all somehow linear, and also the potential mass point are either at 0 or at 1, but definitely not elsewhere. Okay. So one, immediate question is that why is linearity useful, or why should linearity emerge in the optimal, or optimal disclosure policies? So the first observation is that suppose this distribution over posteriors is H is linear, then the seller's demand is going to be constant, or expected demand actually is going to be constant in nature's choice, so long as because she knows that the mean of that option is C. Okay. Why is this the case? Because recall that this term is just the seller's expected demand, and using the change of variable, we swap this by Z. Okay. Oops, sorry. Okay, by Z. And now, because H is linear, and so is this expectation operator, we can move this expectation operator inside of H by linearity. And recall that I talked about this, that this mean of this random variable is exactly the difference between the mean of the option distribution and the search cost. And this is just a constant. So essentially, no matter whatever Weyl distribution nature chooses, so long as its mean is given by C, then the seller's demand is going to be constant. Okay. So recall that really by finding the optimal or like information disclosure policy. We are just finding the equilibrium of the zero-sum game, right? And here it is just a reflection of the smashing penny style equilibrium. Although not as simple, but the idea is the same. So essentially, linearity makes nature indifferent between contracting and spreading the mass and choosing the distribution like G hat of Z, okay? So a nature would also choose G hat in the way that makes the seller also indifferent. And that gives rise to this equilibrium or saddle point of this zero-sum game. And the takeaway here is that linearity is desirable because it hedges well against this malevolent or adversary nature. Okay. And also, you might think that it's useful. Oh, sorry, this is so hard to control. You might think it is useful to have a mass point at the top, because, well, we know that linearity already exclude like the mass point in the interior, but at the top it can be still useful because the seller can pull the mass at the top, which is or let's say at the belief that is sufficiently high for the buyer to buy without search whenever this belief realizes. Okay, and that would help the seller to increase her demand because the buyer is more likely to buy without search. However, notice that, again, there is this malevolent or adversary nature, okay? The nature is going to play a best response to minimize the seller's payoff and to make sure that the nature's choice cannot affect this effectiveness of this mass point to deter in deterring search. It has to be that this point has to be greater than or equal to the sum of the price and the largest possible Z that nature can choose. In other words, the net payoff must be higher than the largest possible Z that nature can choose. And that is given by 1 minus S over C SV, as I just showed above. If you don't remember, don't worry, just remember it. And like this is only possible because this is a posterior, right? If this right-hand side is actually less than or equal to 1, or the price is less than or equal to S over C. Okay, so that means that having a mass point at the top of this distribution over posterior is only helpful in deterring search when the price is less than or equal to this upper bound S over C. Okay, so essentially this highlights the trade-off between demand and extraction in the sense that using a top mass point is helpful like in deterring search, and that also helps the seller to increase the demand, but it must subject to this upper bound of price, so which could actually be bad for surplus extraction. So now to summarize, price higher than this upper bound, a linear distribution without this top mass point is optimal. And for that basically means that what we just saw, the uniform disclosure is optimal. And for like smaller than if price smaller than the upper bound, a top mass point can be helpful in deterring search. And in the interior of the distribution, it has to be linear for hedging against nature, as we just saw. Okay, so we're going to call these two full disclosure and mixture disclosure as deterrence policies because they have this upper mass point to deter buyer search. Okay. All right, so now I'm finally ready to present the main result. So I'm going to talk about it in a very I don't know, like hand wavy or vague way, because I'm going to explain in very much detail next. So for sufficiently small search cost, uniform disclosure is optimal, and the optimal price is actually strictly greater than this upper bound S over C. For sufficiently high search cost, on the other hand, full disclosure is optimal, and the optimal price is exactly the upper bound S over C. Like in the middle sliver between these two boundaries, B1 and B2, like there are like some complexities, but in some cases, mixture disclosure can be optimal. And in what case I'll explain in a little bit. So now let me just get into details. So at this very like blue region here. Okay, so let me just talk about this picture first. So the horizontal axis is the mean of asset option distribution C. The vertical axis is the search cost S. Okay, so this 45-degree line reflects this assumption that the search cost must be strictly less than like the mean of the asset option distribution. And in this feasible region, it is divided to 4 possible areas. And for the blue region, it has the smallest, like search cost. So essentially here in the blue region, the search cost is small. Therefore, the like the upper bound of price when you use a deterrence policy, S over C is also very small. So using a top mass point to deter search would be very bad for surplus extraction and therefore unprofitable. Okay. In this region, it turns out that uniform disclosure is optimal because it gives up like search deterrence, but allow charging a higher price and extracting more surplus. Indeed, the optimal price is much higher than this upper bar. Okay. When the search cost is sufficiently high, we are in this violet region. All right. So here, full disclosure is optimal, as we just mentioned, and the optimal price is exactly coincide with the upper bound, S over C. So first, notice that as the search cost increases, so is this upper bound on price. Okay. That means for a larger search cost, the tension between demand and extraction is alleviated. Why? Because the upper bound is not like super binding. Okay. And here, full disclosure like has 2 effects. First, when the price is less than or equal to this upper bound S over C, it effectively deters search in the sense that whenever the high posterior realizes, the buyer would buy without search. Okay. And this happens with exactly the mu, the prior probability that the match value is high. Okay. So just to recall, so this is the probability that like the buyer would buy without search. Okay. All right. Going back to here. And there's another effect. It maximally differentiates the seller's product from the buyer's outside option, and therefore increases the willingness to pay of the buyer when she knows that her match value is high. So essentially, because the upper bound is like somehow sufficiently high because the search cost is sufficiently large, it would allow the seller to charge a high price. And like to charge a high price and like maintain a good demand, like the search returns effect becomes like important. Okay. And just to summarize, this full disclosure would help the seller to secure a sizable demand while charging a higher price. Okay, so what happens in the middle sliver? I wasn't being very precise over there when I just talked about the theorem. Well, there is a cutoff in the prior probability that the match value is high, namely mu, such that below the cutoff, like namely when the prior is less than or equal to mu, okay? Uniform disclosure or like some cutoff mu hat, not mu, is uniform disclosure is optimal, and it is optimal to charge a price strictly higher than the upper bound S over C. Okay, and below and above the cutoff, the exact the price is always exactly equals to the upper bound S over C when you use a deterrence policy, but different kinds of deterrence policy turns out to be optimal, and that is affected by the the size of the C, mean of the asset option distribution. Okay, so let's not even talk about let's pause or deter our discussion about C for a while. So let's talk about why there should be a cutoff first. So this is basically somehow like the result of these two effects, price versus demand effect. Okay, so the price effect is obvious that in this region, the price is higher when the seller put no mass at the top or doesn't use a deterrence policy. Okay, but the demand effect is that as the prior probability of high match value increases, the buyer is more likely to buy without search, and hence deterring search becomes more attractive to the seller because it boosts the demands even more. Okay, so for sufficiently high prior, the seller would want to switch to would want to use a deterrence policy, either full disclosure or mixture disclosure. But below, the price effect dominates and uniform disclosure is optimal. Okay, now we talk about this mean of the asset option. When the mean of the asset option C is sufficiently high, okay, then we are somehow in the screen region. Buyer is more likely to get a good draw conditional on she searches. Therefore, to soften this competition brought by the sufficiently good asset option distribution, it's better for the seller to use full disclosure to maximally differentiate her product from the asset option and therefore soften the competition. Okay. However, in the maroon region, the mean of the asset option distribution C is fairly small, right? So here, what's important is that when this is the case, when the buyer goes to search, it's very likely she gets an unsatisfactory draw. In this case, it becomes important to attract those buyers who goes to search. However, in this full disclosure, either the buyer buy without search or she just never comes back when she gets she knows that surely the match value is low. However, in mixture disclosure, if the buyer has a posterior in this uniform region, she might very well come back to buy when her asset option draw is bad. Okay, so in this case, when C mean of the asset option is small, it's useful to use mixture disclosure to to make sure that or to attract the searchers to come back. Okay, very good. So that's basically the main results. And so just to recap, again, for sufficiently small search cost, uniform disclosure is optimal, and the price is higher than the upper bound. And for sufficiently high search cost, full disclosure is optimal, and the price is exactly equal to the upper bound. In the middle sliver, there are two regions, the green region and the maroon region we just saw. Both region has this cutoff structure stem from this interaction between this price and demand effects. And below, uniform disclosure is optimal. And above, some sort of disclosure policy can be optimal. Okay, so if you feel very dizzy now, or you like, okay, I can't follow this. Well, first, I apologize. I'm sorry I didn't make it very clear, but at least you can take these last two bullet points home. Like, it should be much easier. First is that the full disclosure is optimal if the search cost is sufficiently high. Second, for lower search costs, different kinds of partial disclosure policies are going to be optimal. Okay. All right, so that's it. That's the main result. Let's see what it explains, or what are the implications for new products. Okay, so there are probably at least 3 kinds of new products. One kind you can think of, it's called evolutionary products. So basically, there are existing products made slightly better. An example was just smart lamps. Just like you can control this light by your phone, and there are a lot of freedom or flexibility in control. It's like, and another kind is revolutionary products. They are much more innovative in the sense that they propose a completely new concept. An example is 3D printer. Okay, and the last kind is alternatives to existing products. It is revolutionary on some aspects, but it has it also loses some existing features. An example is these wireless speakers, which are very stylish, portable, and convenient, but the sound quality is worse than traditional speakers. Okay, and here, search cost, one way to interpret it is it measures how easy it is for a buyer to find her best alternative in the market. Okay, so basically, we can think of revolutionary product being evolutionary product having very low search cost, but let's go back here just to make sure you still remember what it means. Evolutionary product is more likely to have lower search costs because it only differs from existing products in a certain aspects. And it's likely for alternatives to existing products, the search cost is high because they are in completely different direction to the existing products, and therefore it can be much, much harder for the buyer to figure out what's the best alternative. Okay, so for evolutionary products, the search cost is low, and that place it in the blue region of our the picture for the main result, and that shows that providing partial or noisy information is optimal. Examples of this kind of information provision, you can think of offering a short trial period, limiting the number of features available in the free trial, or just offering a sufficiently short product description. Okay, an example is just at the beginning, the e-reader margin note I showed on the first slide. Okay, and for, as I said, alternatives to existing products, the search cost is high, and in this case, full disclosure is optimal. You can think of it's best to divide the potential consumers into lovers and haters and only serve the lovers. Okay, and an example of this kind of policies, you can think of a money-back guarantee, a very long trial period, or a no-hustle return policy with a long return window. Okay, and this e-ink tablet, remarkable, that offers 100 days of return window is an example. Finally, there are some revolutionary products. The key is that the prior, I don't know how, the expectation of the crowd is sufficiently high compared to the mean of the other option. For this kind of products, like the mixture disclosure, having a linear part or uniform part at the bottom and a mask point at the top is optimal. The idea is that like the top mask point that deters search would create some diehard fans, and the rest of the potential customers, fall into the like the uniform area, they get noisy signals. Okay, and the examples of these kind of policies, you can think about iPhone disclosure or Tesla. Okay, so all in all, just summarizing all these, at least these results explains the various kinds of, or large variations of disclosure policies we observe in the markets of new products. Okay. So now let's talk about the comparative statics results I derived from this model. First, the robust price is non-monotone in the search cost. So this is like the picture illustrates how it goes. As I mentioned at the beginning, it's like almost nearly everywhere increasing, but there's a jump down point here. Okay, and also for almost all like parameters, or like a large range of parameters, let's say, for smaller search cost, like the robustly optimal disclosure policy would be less informative. Okay, so let's talk about the price first. So why is this such a strange shape shows up in the optimal robust price? This is because the trade-off between demand and extraction, right? So when the search cost is small, no deterrence don't put the mask point at the top, use the uniform disclosure is optimal, and that doesn't enclose artificial search deterrence. And that would allow the seller to charge a higher price. Okay, that corresponds to this part. However, when the search cost increases, so is this this upper bound S over C for price under a deterrence policy. In particular, the tension between demand and extraction would relax, and the deterrence policy would become more attractive because it increases the demand. Okay, eventually, above a threshold, namely here, the seller would switch to a deterrence policy because the large demand it creates produce a higher profit, even if the price is still strictly lower, like in this region. Okay, so non-monotonicity basically shows that, okay, if you want to think about here, compare here with here, the search cost is much larger here, but the price is actually low. Okay, so how about information? Again, the information part says that for a larger search cost and for most of the parameter values, the optimal disclosure policy actually becomes more informative. Okay, so why is that? But before we answer why is that, first I have to make explain what do I mean by more informative as search cost increases. By more informative, I mean that let's say S1 is strictly less than S2, so S2 is a higher search cost. Basically, I mean that the corresponding distribution HS2 is a mean preserving spread of HS1 as illustrated here. Okay, so why does that correspond to more informativeness? Of course, if you know Blackwell, then it's obvious. But in case you don't know, let me explain to you. So, so basically, to chart so basically, oh sorry, I don't know how to go back. Okay, so as shown here, Oh, sorry. I was a little bit confused. Let me go back to where I was. Okay, so why is this like more informative than it's a mean preserving spread of S1? Okay, because it as a mean preserving spread, it takes these extreme values of posteriors more likely. So basically, look at this part, then these posteriors, fairly high posterior, would never realize under this, and also posterior 0 realizes more likely that this HS1. Okay, so because these more extreme posterior are more likely, that these things are more indicative about the true match value, and therefore, like the distribution HS2, which generates more extreme posteriors, is more informative. Okay, so here, as the search cost increases, as we just seen, like so long as it doesn't cross this or jump down or switching point, the price also increases. Okay, and in most cases, an increased price implies more precise information or a distribution that is the mean preserving spread of the previous one. Why is that? Because to charge a higher price while maintaining a reasonable demand, the distribution over posterior must generate these high posterior more often. Otherwise, why should the buyer still buy from you? Okay, but since the only restriction we put on the distribution over posteriors is that the expected posterior must be the prior, to increase the frequency of high posterior, there must be a commensurate increase in the frequency of low posteriors. All right, so that generates like the extreme posteriors more often, and therefore generates a mean preserving spread as the price increases. Okay, and furthermore, if like the search cost crosses the increase in search cost crosses the switching point, it calls for providing more information when the match value is high, because now you remember there is this top mass point when this thing realizes the buyer is sure that the match value is high. So crossing the jump down point or switching from a uniform disclosure to a deterrence policy also makes the disclosure policy more informative. These two effects goes hand in hand to make the statement true, in the sense that for most parameter values, for more informative as distribution over posteriors becomes more informative as search cost increases. Okay. Okay, cool. So all right, so the implications of these comparative statics results are as follows. First is that although there might be some advancement in technologies helps to lower the search cost, but for some new products, it might increase the price and make the information provision to be noisier or less precise, actually hurts the buyer. Okay. And also, one reason for charging a low price in selling new product is that when we consider information provision, it might be that the seller wants to use this low price to pairing with the information to more effectively deter buyer search, and that might actually be a reasonable behavior rather than a bad habit mentioned at the beginning. Okay. All right. So lastly, let's talk about some variations and extensions for the model. So I'm going to talk about two variations of the model. And first of it I shut down the search cost, so there's just the buyer does not need to search to find the outside option. You can think about, like outside option is already there. And another one is that, so basically the search frictions are, like shut down here, okay? Another one is that I assume the seller knows the outside option distribution. So essentially, she just like, there's no, I don't know, like robustness seeking anymore. Okay, so these results are like useful in the sense that it answers a question of what like implies what, or what assumptions implies what features of the optimal selling strategies. Okay, so first, suppose the search cost is 0. Strikingly, uniform disclosure, remember that, like uniform distribution with no mass point at the top, is always optimal. And the robust price is just like, P naught, which is the search setting. Oh, sorry, here. There's a typo, but let me just not talk even about the robust price. That's fine. But importantly, the optimal disclosure policy is always like this uniform disclosure. So that basically shows that when the search friction are absent, the trade-off between demand and extraction disappears, because the seller can no longer deter search to increase her demand. Then, because the seller wants to hedge against nature, that would render this linearity, namely uniform disclosure, optimal. In particular, the disappearance of the search frictions shut down the search deterrence motive that would make the top mass point disappear. And in particular, full disclosure would never be optimal. But at least we see that it is because the seller is seeking robustness, that renders this linearity part of the main result. Okay. And another benchmark or what is that when the seller, as I mentioned, knows the outside option distribution G. So now, first, she is no longer that she has insufficient information. And 2, it's also that she doesn't need to have this robust seeking behavior or robust objective. Okay. So here, this is just a technical assumption. What's striking about this case is that full disclosure is always optimal. Okay. So, of course, it doesn't mean that using full disclosure is always equivalent to search deterrence in this case, because if you charge this price 1 minus A, basically because the outside option distribution G is known, so this is possible, then the buyer would buy without search when she gets the high, and she knows that her match value is high, because in that case, the posterior is 1 and minus this is exactly A. Okay, then she would just, indifferent between searching or not, she would just not to search and buy immediately. Okay. However, it could also be possible that the seller charged this PH. This price would just allow the buyer to search, and she would only sell to those who find her outside option not so attractive. Okay. So why is this outside option distribution? Sorry, the optimal information disclosure policy always being full disclosure? This is because, first of all, maximally differentiating the product from the outside option would be optimal. But also, you might wonder why this is not necessarily always optimal in the main model. This is because the hedging motive, or let's say there is a upper bound for using the deterrence policy in price, right? Or using a mass point at the top. Otherwise, the nature might mess things up. in that case, even if you maximally differentiate the product from the outside option, that need not allow you to extract a lot of surplus because you face an upper bound for price. So you might either want to switch to uniform disclosure to charge a higher price, or in some cases, this mixture disclosure might actually generate a higher demand for you. That basically going back to this benchmark, this absence of hedging motive makes maximally differentiating the product an optimal, because that would allow the seller to attract or to extract a lot of surplus from those whoever gets the high and knows that their match value is high. Okay. Okay, so lastly, there is one interesting feature that the main trade-off between demand and extraction would still persist, because when the search cost is sufficiently small, the seller still wants to allow the buyers to search to charge that would allow her to charge a higher price. But when the search cost is actually higher, she would prefer to deter search, because this 1 minus A, this stopping threshold A is increasing in this search cost, and that would be decreasing the search cost, that would yield a higher price. Okay, and also because of this main trade-off persists, this feature of non-monotonicity of price also remain, in the sense that at some cutoff, the optimal price would drop, having this jump down point. Okay, and in particular, it's interesting that the seller, when has less uncertainty about the outside option distribution, it is actually generating more precise information provision. And of course, there's a reason I don't study this, you use this benchmark model as the main model, because in full disclosure is always optimal, and it doesn't match the large variation of selling new products in the markets of new products. Okay. Cool. So let me just talk about some extensions, since I think I have 14 minutes probably. Very good. Yeah. So I might not be able to talk about them in a lot of detail, because that might take a lot of time. But essentially, if you one possible extension is that I could allow. So remember, in the model part, I assume that the buyer's identity is anonymous. Therefore, the seller must charge the same price to the first time visitor and buyers who come back from search. Okay. But here, if we allow the buyer's identity to be recognizable, one possibility is that the seller, well, that's strange, can take advantage of this to make an exploding offer. What does that mean? Is that she commits not to sell to the buyer if she doesn't buy in her first visit. She may also post a price first, and then if the buyer comes back, she knows that, oh, this guy came back just now. That's great. So let's increase the price, because she comes back means that her outside option is not that good. Okay. So what would happen if this is the case? Well, if the seller can commit to an exploding offer, then she would go with full disclosure and sets a price that extract full surplus. Okay, and furthermore, if possible, she would always want to make this exploding offer. Of course, so long as she can recognize the buyer's identity, because that makes her earn strictly higher revenue guarantee or profit. So the intuition here is that like exploding offer is outcome equivalent to that the outside option distribution is the degenerate distribution or point mass at this mean of the outside option distribution C, right? Because the buyer must decide before to leave or not, before checking or like ever discovering the outside option itself. So the only information she can use is the mean, right? But that's not good for the nature, because if she can choose, she wants to use some other other distributions rather than this one. Okay, so here nature has no call at all, and that would make the seller actually take advantage of this and earn a higher profit. In particular, full disclosure is optimal because it creates the highest possible total surplus, and the seller can appropriate all the surplus because the outside option is effectively a fixed number of C. Okay, so she just charge one, which is the when the buyer knows that her match value is high, minus C minus S is the value of the outside option, and therefore that makes full disclosure optimal. Okay, so furthermore, if the seller cannot commit to the price, if this is the case, well, in general, there's not a lot to say. But if we just assume, no matter how small it is, a cost of returning to seller, then this buyer would never go back to the seller using a standard, I don't know, because of time, I wouldn't go into details, diamond paradox style argument. And therefore, the outcome is the same as if the seller is committing to exploding offers. This is the same as the seminal paper of Armstrong and Joe, if you want. And another possibility is that the seller can take advantage of recognizable buyer identity to do price discrimination. Okay, so suppose disclosure policy has to be fixed, but the seller can commit to a price pass with if you buy now, it's cheaper. If you come back, it's more expensive. Okay, so these two things are basically P1 is the price charge if the buyer buy immediately, and P2 is the price charge if buyer only buys after search. Okay, so essentially, if this somehow I call it deviation, that deviating from this robust price or robustly optimal price PR in the baseline model to this price pass cannot be detected by nature, and therefore she still chooses this original outside option distribution, then seller can benefit from such a deviation. That's the same reason as in Armstrong and Joe. However, if nature can actually detect this deviation and optimally responds to it by choosing a new outside option distribution, the seller cannot benefit from such a deviation. This is because nature can choose this new outside option distribution such that it is as if the seller is only selling to the buyers who is buying now. So the second or higher price is now useless, okay? Or doesn't help the seller. All right, so with the last couple minutes, let's talk about a few other extensions in quickly, and I'll conclude. So if the search cost distribution is if the search cost is no longer exogenous, but is actually a distribution that is designed by the nature that the seller only knows the mean and the support, then the main, results would, yes, please. 请讲，有人举手吗？请讲。没关系，可能。这个是有人举手还是？ 好，没关系，那我继续。So in this case, in this possibility, the second one. So basically, anything else is going to be similar, but like it's just that search deterrence strategies, or sorry, deterrence policies, not strategies. Sorry for the typo, is going to be less attractive. But again, the main qualitative features of the results hold, or the main insights also hold. Okay, we can also allow, assuming a safe outside option, let's just call it U0, that's strictly greater than 0, that the buyer can consume without incurring the search cost. So this is an extra thing, like that she can either go to this one, or she goes to search for like our free, or she goes to costly search for like outside option according to this distribution. Okay, this would also not change the qualitative features of the main results. Of course, one very I don't know, like intuitive, or let's say natural possibility is to ask that what if the buyer's match value is no longer binary 0 or 1 or low or high, but rather distributed continuously on an interval. In this case, many insights actually carry over, including the trade-off between like demand and extraction, and also that like the optimal distribution might be linear because that hedges well against nature. However, like not too much can be said about the, I don't know, comparative statics, or like because, or other stuff, because, you know, like in this problem, it's very difficult to characterize the optimal price. So finally, there could be some alternative assumptions on seller's knowledge. Recall that in the main model, seller knows that the mean of the outside option distribution is C, and the support is in this unit interval. Of course, in all these possibilities, I'm assuming that the seller is still robust seeking. If instead this upper bound of the support of the outside option distribution is sufficiently large, then using a mass point to deter search is never profitable, and therefore, like uniform disclosure is optimal. Why isn't it never profitable? Because nature has a lot of leeway here to always, like, you know, how do I say this? Nullify or neutralize the choice of a mass point whenever she wants. Okay, and if instead the support like is like, you know, from the exactly the positive real line, but the seller further knows that like there's I don't know, like upper bound on variance, not necessarily variance, just some convex moment. Okay, then the only difference is that the distribution could be, instead of linear, can be convex, but the main insights are going to be unaffected. Okay, so let me conclude. I, in this paper, characterize the robustly optimal way of selling a new product when the seller sets a price and also chooses how much information to disclose about the product. She also faces like uncertainty over the buyer's alternatives, and she tries to seek robustness to it by choosing a robustly or max mean, using max mean approach. Okay, the seller trades off between demand and extraction, and that results in the feature that full disclosure is optimal only when the search cost is high. Otherwise, disclosure is going to be noisy, or it's partial information provision. And for comparative statics, I show that the price is non-monotone in the search cost, and information provision is likely to be more precise as the search cost increases. So I believe these results have concrete implications for the sale of different kinds of new products. I talked about these evolutionary products, alternative to existing products, and revolutionary products. And also, there's a caveat that as the search cost decreases, the buyer might not actually be better off. And Finally, these results shed light on like the variety of price and information combinations be observed across new products in the market. Okay, that's it for today's talk, and thank you a lot for coming. Yeah, 好，谢谢，我讲完了。
Okay, first I have a question. If what if as a buyer I can choose to check the outside option before checking the current product? I mean, intuitively, I might not want to do that because I can freely check what's provided first and then decide whether I want to search. But maybe that would change the incentive for the seller to provide, information or pricing offer. So I'm just asking.
Yeah, great. This is a really good question. So essentially, in some sense, like as you said, the buyer might not want to do that because why, right? Like why don't I just see what is freely available first? But what if let me just think quickly if what if like this is really the case. Okay, I guess when this is going to okay, suppose this is the case, then the problem for seller is anyhow going back to here, the zero search cost. Does that make sense? And then
yes, but I mean, if the buyer can make it observable to the seller, then the seller's incentive.
Oh,
change,
now there's screening, but then I don't know. Like
okay.
I don't know what's going to happen if there's screening. Yeah.
Okay.
Yeah, sorry about that. But I guess if that's the case, then I don't know. Probably it's very similar to this paper of I don't know, Don Wei and Brett Green.
Okay.
Somehow similar because the outside option you remember they have this additive separable between value and taste.
Right.
And then taste is a type and the value is but if you just remove this, I don't know, the taste part to the right hand side of the inequality, then it's the same. So I guess what's going to happen is similar to what they're doing. Yeah.
Okay, that's interesting. That's my question.
I have a question.
Cool.
It's about the second last page you mentioned. Said that most of your results carry forward to the case when the types are continuous, right?
Yeah, I mean not really most.
I'm wondering like one of the intuition of this extraction is because you have this 0 and 1 realization. So in that case, right, you do have these extractions that like to deter the search. But in a continuous type case, how could you deter the search completely?
That's a great point. That in the sense that you would never be able to deter search completely. That's correct.
Right.
However, you can always pull at, like if you are familiar with these at some point at the top, in the sense that you contract the mass of the distribution to one point for some upper interval. It's called somehow upper censorship in the literature. And in that case, you can still somehow to deter this part of buyer from search. Yeah. But of course, it's not as stark as the two types case. That's right.
Okay. Yeah. Thanks.
好，那看一下其他的参会的老师和同学有什么问题吗？好，如果没有问题的话，今天非常感谢张坤带来这个一个非常有趣而且结果非常丰富的这样的一篇文章。如果大家有进一步的问题，后续想要和他进行这个交流的话，可以通过他的邮箱或者是 OK， 对，这是你的网站的二维码吗？
对，网站二维码。如果大家对我这个其他的这个工作感兴趣的话，可以去看一眼。
对。好如果是没有进一步的问题的话， 那我们今天的 seminar 就到这里啊，然后这个张坤可以移步到另一个腾讯会议啊，我们接下来和2位同事有一个1对1的